Okay, so random forest uh, regressions are exactly similar as our previous regression, which was decision tree. Okay, but I just want to get confirm that what was the last thing. Decision tree I have shown you, right? Okay, okay. So decision tree regression, just a quick understanding of decision tree. Let me show that also, so that okay. So decision tree regression, as we had mentioned here, if we have a data, it will split it up. Okay, and we will get these kind of boxes, right? Now in a random forest regression, what it will do is it will out say, imagine this, there are 100 red points. Okay, imagine there are 100 red points here. So in that case, what it will do is it will randomly take, say, 15 points first. 15 points it will take randomly, and it will create these kind of splits for that those 15 points. Okay, it will create these kind of splits for those 15 points, and then again it will randomly take the next 15 points from these points, and again it will create splits, and similarly it will do it for all the different 100 combinations. Okay, so we will get multiple splits and multiple uh, uh, categories. Okay, so there will be, say, random different points, so we will get different type of splits, and hence finally what it will do, it will if a new point comes, it will take the average for all the cases. So if there are 10 different cases, then it will give you 10 different answers, so that average it will take, so you are going to get a better result. Okay, so let me show you once in the first. Pick up random k points from the training set. Random k points builds decision tree associated with those k points. Okay, it will create decision tree. Choose number of entries you want to build. So it is up to us how many trees we want to build. Okay, then for new point, makes each of the entry predict the value. So if there are 10 entries, okay, then 10 different values you will get, and for those 10 values, it will take the average and it will show you the predicted answer. Okay, so I will show it in the graph one. This one, paint. See, this is your full decision tree, actual decision tree. Okay, but now what will happen is it will create a small subtrees. Okay, here it will randomly pick some points. Okay, say 15 points. It will, if randomly it will take 15 points. So imagine those are here. Imagine these are this 15 points from this randomly it will pick. Then here it will create decisions. Okay, imagine it did this. Next time it will take another random 15 points. Okay, so you will get like this. Now it will do decisions based on that, so you will get this point. Like that it will split, and it will do for n number of trees. So imagine you did 5, so for 5 different cases it will do. Then when a new point comes, say the new point is blue. Okay, new point is blue. Then it will put that new point in all these five different trees, and then it will do all the five will predict the answer. Then the average value will be taken, and hence we are very close to the real case. Okay, let us see the solution here. Here code is very simple. Okay, position salaries, which this is already known. Only thing which is changing is here. Okay, number of estimators, number of trees, 5. Okay, and regressor dot fit, that is also same. Regressor predicting the value, here I'll put predict, and if I run this, see for 6.5, okay, between 6 and 6.5, it is showing me as 15,200. Okay, experience it is showing. So the number of stands have increased, so it is slightly better than decision tree. Okay, so we are getting this value. I'll share the code, you guys can try this, and then we will go to a new topic. Yes, you guys can check. I will be back in 30 seconds. You can maybe 2 minutes, you guys can go through this code, and I will come back. Okay, so now see, I wanted to tell you about that assignment for analog design. Okay, and you have very few days left. Okay, so that analog design, I had shared your name across that. So you guys have to prepare, and you have to prepare a report. Okay, so I will be sharing assignment for not assignment. It is a final project. Okay, that internship final project. See, one project in analog design and one in machine learning. Machine learning end of this week I will share. Okay, so for analog design I already shared, so you should try to finish that soon. Okay, if you guys have not understood or something, if you need some help, I will do one more session on analog design, a common class. Okay, so make sure you guys prepare that as well. Okay, or else we will not be able to finish it. You guys can refer the old lectures, and some lectures are also there in that YouTube channel, my channel only. You will get so already everything is done. Okay, you have to just add a few things in series and you have to do it. Okay, if you have any doubts what is to be done, you can ask me. Okay, another minute, yeah, I will start. So now we have finished almost all the regression algorithms. Okay, so here we can do this regression now on any other data. Okay, so if I give a data, so now what is regression data? So that is very important. When before you they see there are like six algorithms. Okay, which are this? First is simple linear. Second one is multiple linear. Third one is polynomial. Fourth one was SVR. Then decision tree. Then it was one second. random forests. Okay, so now if you get a data, no one will tell you that this is falling under regression, you should do apply regression. Okay, if you get a data set, you should first know whether I should apply regression or not. So all these things will fall under regression. Okay, so you should know when to use regression. That is the first important thing. Okay, so if you have seen a data which is you have already seen, which is continuously varying like this, so this or this, both of them are falling under regression. So first step is you should see a data whether it is falling in this category, okay, this kind of form or not, this kind of form or not. Only then you should apply all this algorithm. So if it falls in this algorithm, in this style, it falls in this style, then you guys can start applying all the 6 algorithms, and then check which is the best among this, and then you can continue. Okay, now there is a formula to find the efficiency of the algorithm. Okay, what is that formula? We'll see. The formula is simple, which is called as R2 score. Okay, R2 score. This will help you to understand what is the efficiency with which this algorithm is doing the prediction. Okay, so it will take the predicted value and the actual value, and it will tell the R2R score. Okay, if I to print, y test is not defined. Okay, we can apply it some other place. Okay. Okay, so here I'll apply that. Okay, so for multiple linear regression, it is giving me an efficiency of 0.93. Okay, so now you don't have to visually see it. You should actually see both the way. Okay, visually also you should see, and this way also you can see and tell what is the prediction. Okay, I will share this. You guys have to ensure that it, see, when you are doing this, you should have y test and y pred. Okay, so that's why in the previous code there was no y test and y pred. That's why it was showing error. Okay, now I will share this complete code so that if you have data, you have to just see the efficiency there. Okay, data.csv already you have. I'll share this. Just try to see this. See, okay, not here. I will share it in mail. So I want, see this. The purpose of doing this batch was so you guys can open up, and you guys can, if you have doubt, you can talk. That was one of the reason here of for creating this batch. Okay, so I want to understand how well you see. Now next topic we are going to classification. Okay, so are we, the was the purpose of creating a slow batch, has it helped, or you guys are still facing the problem? Okay, whether the slow batch was needed or not, or else we can, I will try to change further, because now once the regression is over, I will go to classification. So if you whatever I have taught till now, is it has it impacted you, or you guys can now make small changes in the code and you guys can start predicting things? Those things you are able to do, or you are still facing problems? You guys can reply in the chat. Okay, so okay, good. Fine. So others, if you're not able to see this now, almost we'll finish it in one or 1.5 week. We'll finish our thing. So better you, if you have any comments, you can tell me now. Okay, so that I will be able to change. Okay, or else okay, two of you are saying okay, fine. Okay. So this regression you understood. Now we will go and check one more thing, classification. Okay, today we will see classification. So the data set should be different. Okay, classification and regression, the data set will be different type. Okay, now classification is something like head and tail. Okay, head and tail, yes and no, and true or false, he will purchase or he will not purchase. Okay, that kind of scenario. Okay, then you can use classification. Okay, this will fall under classification. Regression, we have seen whether how to apply, when to apply regression, when to apply classification. You should know. You should after seeing some data set, you will understand it. Okay, now let me show you example of data set. Okay, so this is a data set called as social network ads. So here, okay, here this is the age, this person's salary. Okay, this guy is getting 19,000 and he has not purchased this product. Okay, there is a product. Imagine this is a mobile phone. Okay, this is a mobile phone here. Okay, I'll put some dots. And I have created an ad, and these people have seen those ad. Okay, there are like 1,000 people, and all these 1,000 people have seen this mobile ad, and out of this, following people have purchased the mobile. Okay, these people have not, and here again these people have purchased this mobile. Now when I want to go to a bigger uh, customers, okay, so there is a bigger volume of customers. I will see my 1,000 customers and start analyzing who has purchased and who has not purchased my product. And then what I can do is I can do a targeted ad where I can use that ad for people who will actually purchase my product. Okay, that way I will be able to uh, get more customers. Okay, and you can see here, generally people who are in their 40s have purchased this product. Okay, people who are in their 40s have purchased this product, and who are young, say 19, those age, your age guys have not purchased this product, they are not interested. Okay, so I should make sure that this product goes to the right category of people. If I come and tell you please purchase this product, please purchase this product, you will not purchase. Maybe some senior guys, if I go and if I tell them to purchase this product, they will think of purchasing it. Okay, and also the salary. Okay, the salary whose less salary is less, they have not purchased. So seniors whose salary is more, they have purchased. So all these categories are important. So here it is 0 and 1. So true or false kind of thing. Okay. So here I need to apply classification and I have to see. So we will see the algorithm. The first regression is logistic regression. Okay. So here logistic regression, this is the data. Okay. So this is new action, yes or no. Okay. Here, this was our previous uh, algorithm. Okay, this was our previous algorithm where there were points here, and we were estimating it by drawing a line. Now our data set is different. Okay, if you see this data and this data, you can see a clear difference. Okay, here it is in this form. Here there are two groups, clear two groups are present. Okay, there are two groups. Now how do you create an algorithm which will ensure that it will take this group and this group separately and it will start predicting? Okay, so for that what we do is, first we draw a straight line and then we will do this slight bending of it here. Okay, and then, so to do this straight line, we use simple linear regression formula only. So this straight line is drawn using linear regression, and then to do this bending part, we use these two things. Okay, sigmoid function we will use, and we will get this bended part. Okay, once that is done, we will draw lines. Okay, with the efficiency, so 20% efficiency, 30% efficiency, we will see at what point we will get 50% of people in one side and 50% of people in another side. See, maybe at 50% point only we will get it, or maybe at 40% point we might get 50% people in one side and 50% in another. Then we will draw a line in between and we'll say that all the people who will fall here below this will not purchase, and everyone who is above this is going to purchase. Okay, this is what our algorithm will predict, and it will tell if a person's age is below this line, then he is not going to purchase. If it's above this line, he will going to purchase. If his salary is above here and he will purchase, below this he will not purchase. Like that it will do the estimation. Okay. Now to this algorithm, what we are seeing is called as logistic regression. Okay. This is so classific. The name of this algorithm is logistic regression. So it will act like regression only. So because you can see it is drawing a line here. A regression type, it's a form of regression where it is applied in classification. Okay. So this is one form of algorithm. Now I will before that we will see the code once, logistic regression, and how the output will look. Okay. Before I share the code. Okay, so now this is the social network ads. So first step is same. There is no change in the first step. Second step, splitting is also same. No change in that splitting form also. Here we need to do scaling. So if you remember what is scaling, we will do like GPA system. Okay, person who has got the highest marks in the class, we will take that value and divide the marks to all the students. Okay, so if one person had got 90, that person will become 1 and others will become lesser than that. Okay, that is called GPA. Here also same scaling. So it will take the something similar. It will not take exactly the highest value and do that, but it is going to scale and bring down the numbers which was in hundreds or thousands to around 1, 1.1, in that range it will bring, and you will get X test and X train. Okay. Why we are not applying it Y train and Y test? Y train and Y test is already 0 and 1 form. So we need not do that. Okay. Next step, scalar linear model. So here we are applying the algorithm over. So once we do this transformation, then we will apply our logistic regression with the random state 0, and we have already trained. So these three trainings will train our algorithm. Next step is seeing how well the algorithm has been trained. So we have to pass some values and check. Since we have to do transformation, we cannot directly pass 40,000 and 1,27,000. We have to use sc transform, and then we will be able to do it. Okay. Then we can also do ypred classifier predict y test. Then you will get ypred. Then there is first you do this. You can run the algorithm till this point. Then I'll explain again the remaining part. I'll also share the data set. Okay, so I have shared the code. You have to just run this, and you will get the answer. Check what it you are getting. When I will run here, yeah. So the answer is 1. So what does this 1 signify? 1 signifies that this person whose age is 40 and whose salary is 1,27,000, he is going to purchase my mobile. If I make this salary as 27,000 and this age as 20, so it's your age person. Okay. Now if I run this, he is not going to purchase. You guys are not going to purchase my product. Okay. Next, this is you are seeing manually the things. Okay. Now if I want, there is something called as confusion matrix. What is confusion matrix? We'll see. This is our confusion matrix. Okay, I will explain that. See, this is our confusion matrix. Okay, this one. So in this confusion matrix, it is saying that there are total 68 cases where people have not purchased. Okay, there are total 68 cases, and my algorithm has predicted 61 correctly. 65 it has predicted correctly, and 3 it has not predicted correctly. Okay, and there are 32 cases where people have not purchased the product, and out of which 8 cases it has predicted wrongly. Okay, that people who have purchased, it has thought it has purchased, but people have actually not purchased. Okay, and then 24 cases it had predicted correctly. So 65 cases and 24 cases are the right cases of each category. Okay, and 3 and 8 are wrong things of this. Okay, that is called as confusion matrix. So that why we need confusion matrix. It is a visually we can see how many things went wrong. Okay, actually for example, I came and I thought out of you there are like 8 students, I thought two will purchase, and actually you guys are not purchased. It is something like that. Okay, this also gives the accuracy score. Okay, this confusion matrix, no, there is also a module which will also tell accuracy score, and if you pass y test and y pred, you will be able to find the accuracy. Okay, for that purpose you will get 0.89. So this algorithm logistic regression is showing an efficiency of 89%. Okay, now there is a nice way of visualizing this data. Okay, and you should know that visualizing you can do only when there is two columns. Okay, and output is always one column. If there are two x columns, okay, then we can do prediction here. If there are more than two columns, we cannot do visual prediction. We can only see confusion matrix and accuracy score. So you cannot apply if there are four columns and one answer column. Okay, you cannot do visualizing that. Okay, it will give error. In that case you can only see accuracy score. Okay, you should remember that. Now let me run this. It will take time. It will come. It is a, so it will take time. Okay, this algorithms will take time classification. So sometimes you can just run it and leave. It will take time. Meanwhile, I'll share the code so you guys can also run. Yes. So yes, so this is a beautiful plot. Okay. So what does this plot signify? This plot signifies that two cases, okay, head and tail case. Similarly, for people who have purchased, let me take the black blue pen, okay, purchased versus not purchased. It has done two groups, and all the red are actually purchased. Okay, so this actually purchased. So our algorithm, these people are should be actually falling in this category. Okay, they should call in this category, but algorithm has predicted wrongly here. And whereas this green ones who had actually not purchased, they are in this category. They should be in this category, but it has seen it in this form. Okay, so these are the problems which it had. So this is how the algorithm will tell. So from here you can say that actually there should be only green dots in this region, and this should have only red dots, but few of them are. This algorithm which has done a simple linear line is not sufficient. Okay, actually the algorithm should do something like this, so that it will cover the exact people who are going to come, and the accuracy of that algorithm would have increased. But logistic regression cannot do that. We will have to go for some other classification algorithm which will be able to do that. Okay, now you guys can run and check. So about this graph, okay, there is a massive big code here. You guys can try to understand that. If you don't understand it and how it is done, I will explain that. This is falling under a category of contour plots. Okay, you guys can try to run this code and tell me if you have any doubts. Try for 10 minutes.